The day the sun disappears. August 12, 2026. Imagine standing outside in the middle of an ordinary day. The sun is shining, people are talking, cars are moving, birds are flying overhead. Everything feels completely normal. Then something begins to change. Slowly, almost unnoticed at first, a dark shape begins moving across the sun. The daylight starts to weaken. The temperature begins to shift. Shadows become strange. The sky starts taking on a color that doesn't quite look like morning, afternoon, or evening. Then, for a few extraordinary moments, the sun disappears. Day becomes darkness. Stars and planets may begin appearing in a sky that was bright only moments earlier. And surrounding the black circle where the sun used to be is something normally hidden from human eyes. A ghostly white atmosphere stretching millions of miles into space. This is the solar corona, and on August 12, 2026, people across parts of the northern hemisphere are preparing to watch it happen. A total solar eclipse is coming. And although eclipses have been happening for billions of years, there is something about watching the sun disappear that still makes even modern humans stop what they are doing and look toward the sky. On August 12, the moon's shadow will sweep across a narrow path stretching through northern Russia, Greenland, Iceland, across the Atlantic Ocean, through Spain, and into a small section of Portugal. People standing inside that narrow corridor will experience totality. For them, the moon will completely cover the bright face of the sun. Outside that path, millions more across parts of North America, Europe, and northwestern Africa will experience a partial solar eclipse instead. But perhaps the most remarkable part of this event is how ordinary the objects causing it actually are. There is no explosion, no mysterious force, no change in the sun. Nothing is attacking Earth. It is simply geometry. The moon passes directly between Earth and the sun. From the right location, at exactly the right moment, the moon appears large enough in our sky to cover the sun. That sounds simple, but the coincidence behind it is extraordinary. The sun is roughly 400 times wider than the moon, but the sun is also roughly 400 times farther away. That combination makes the two objects appear surprisingly similar in size when viewed from Earth. And because of that relationship, our relatively small moon can briefly cover an enormous star. Think about what that means. The sun could contain more than 1 million Earths by volume. The moon is tiny compared with it. Yet from where we stand, the moon can slide perfectly across the sun and temporarily erase its brilliant surface from the sky. That is what makes totality possible. And it is totality that transforms an eclipse from an interesting astronomical event into something people sometimes spend years traveling around the world to experience. At first, the eclipse doesn't look particularly dramatic. The moon begins covering a small section of the sun. It looks like someone has taken a tiny bite from its edge. Then the bite grows. Minutes pass. More of the sun disappears. But strangely, the world may still look relatively normal. The sun is incredibly bright. Even when a large portion of it is covered, the remaining sunlight can still illuminate the landscape. That is one reason looking directly at a partial eclipse is dangerous. Your surroundings may appear darker, but the uncovered part of the sun remains powerful enough to injure your eyes. Regular sunglasses are not enough. NASA advises viewers to use proper eclipse glasses or safe handheld solar viewers throughout the partial phases. And cameras, binoculars, and telescopes require specialized solar filters mounted over the front of the optics. Only during the brief period of complete totality, when the sun's bright face is entirely covered, is it safe to look directly without those filters. The instant any bright portion of the sun returns, eye protection must go back on. But for people safely watching from inside the path of totality, something remarkable begins happening as the final portion of sunlight disappears. The light becomes unfamiliar. Colors can look different. The horizon may remain illuminated while the sky overhead grows dramatically darker. Animals may begin reacting to the sudden change. Birds can behave as though evening has arrived. The air may become cooler. And then, the last brilliant points of sunlight shine through valleys along the edge of the moon. For a few seconds, those bright spots can resemble a string of jewels. Then, the final point disappears. Totality begins. And suddenly, the object humans are told never to stare at becomes a black circle surrounded by a glowing crown. The corona. The sun's outer atmosphere. Normally, the corona is invisible to us because the sun's surface is overwhelmingly bright. But when the moon blocks that brightness, the corona appears. White streams can stretch outward from the black disk. Bright pink or reddish structures called prominences may sometimes appear along the sun's edge. And for scientists, these few minutes provide something incredibly valuable: a natural laboratory. The corona is one of the most fascinating and mysterious regions of the sun. Its temperature can reach roughly 1,000,000 degrees. That creates a strange scientific puzzle. The visible surface of the sun is much cooler than the corona above it. Scientists are still studying exactly how energy moves through the sun's atmosphere and heats the corona to such extreme temperatures. Solar eclipses give researchers an opportunity to observe regions close to the sun that can be difficult to study under normal conditions. And NASA isn't simply waiting on the ground for this eclipse. Scientists are taking to the sky. During the August 12th eclipse, a NASA WB-57 research aircraft is scheduled to fly at approximately 50,000 feet. Mounted inside the aircraft will be cameras designed to record the solar corona in several wavelengths of visible and infrared light. The cameras are expected to capture at least 20 images every second. Scientists hope those images will reveal structures and rapid changes inside the corona and help researchers study solar material, the solar wind, and the mystery of how the sun's outer atmosphere becomes so hot. There is another reason for putting the experiment on an aircraft: speed. The moon's shadow will be racing across Earth. Someone standing on the ground gets only the amount of totality their location provides. But an aircraft traveling in the same direction as the shadow can chase it. For this eclipse, the longest totality visible from the ground will be about 2 minutes and 18 seconds. NASA says its aircraft, traveling along the eclipse path at around 460 miles per hour, should extend its observation of the corona to almost 3 minutes. That may not sound like much, but when scientists have only minutes to observe an astronomical phenomenon, additional seconds are valuable. And above the clouds, the aircraft has another advantage. Weather becomes less of a problem. For eclipse watchers on the ground, clouds can destroy months or even years of planning. You can travel thousands of miles, book a hotel, choose the perfect location, wait for the exact day, and then a single layer of clouds can hide the entire event. At 50,000 feet, NASA's aircraft will fly above most weather that could block the view. But the sun isn't the only thing scientists are studying. They are also studying Earth. Because when the moon blocks sunlight, our atmosphere reacts. NASA-supported teams are preparing to launch scientific balloons from Iceland and Spain before, during, and after the eclipse. In Iceland, teams plan to launch dozens of balloons to study changes in the lowest part of the atmosphere. In Spain, balloons carrying cameras and scientific instruments will observe the moon's shadow and measure atmospheric changes, including ozone. Previous eclipse experiments found measurable changes when daylight suddenly disappeared. The 2026 eclipse gives scientists another opportunity to understand how Earth's atmosphere responds when the normal rhythm between day and night is interrupted for just a few moments. And that idea makes an eclipse even more fascinating. The moon's shadow doesn't simply change what people see. For a short time, it changes the environment beneath it. Sunlight decreases, temperatures can fall, atmospheric conditions respond. Animals notice, people notice, sensitive scientific instruments notice. For a few minutes, a shadow moving across Earth becomes a giant natural experiment. The location of this particular eclipse also makes it unusual. In Iceland and Greenland, totality comes during the late afternoon or early evening. In Spain and the northwestern tip of Portugal, the sun will be very low in the sky. Totality there will happen shortly before sunset. That means some observers may see the eclipsed sun hanging close to the horizon. Instead of darkness arriving from directly overhead, the event will unfold against the colors of evening. And for many locations farther outside totality, the sun will actually set while still partially eclipsed. Spain is becoming one of the main gathering places for the event. The European Space Agency says this will be the first total solar eclipse visible from mainland Spain since 1905. ESA is organizing public events and a live broadcast, while scientists and eclipse watchers from around the world are preparing to travel into the path. Think about that for a moment. Generations of people have lived entire lives in Spain without seeing totality from mainland Spain. Then, on one evening in August 2026, the moon's shadow will return. People who have never met will gather in fields, cities, mountains, and observation sites. They will speak different languages, come from different countries, have different beliefs, different occupations, different lives. And for a few minutes, almost all of them will be doing exactly the same thing: looking up. That may be one of the most powerful things about eclipses. Modern life rarely stops. Phones buzz. Messages arrive. Meetings happen. Traffic moves. Markets open and close. News changes every minute. But when a total eclipse begins, thousands of people suddenly stop paying attention to everything humans have built and watch something that would have happened whether humanity existed or not. The moon doesn't know anyone is watching. The sun doesn't know it is being covered. Earth continues moving through space. There is no performance, no countdown built into nature, no audience required. And yet, humans have been fascinated by eclipses for thousands of years. Long before astronomers understood exactly what caused them, eclipses could be terrifying. Imagine living centuries ago. You don't know about orbital mechanics. You don't have astronomy apps. There is no scientific prediction telling you what will happen. Then one afternoon, something begins eating away at the sun. Daylight disappears. The sky darkens. And the most powerful object in your world appears to vanish. Different cultures developed stories to explain what they were seeing. Some imagined animals or supernatural beings swallowing the sun. Others interpreted eclipses as warnings connected to rulers, wars, or dramatic changes. Today we understand the mechanics. Astronomers can predict eclipses decades and centuries in advance. We know where the moon's shadow will travel. We know approximately when it will arrive. We can calculate the length of totality. Satellites observe the sun continuously. Spacecraft study its atmosphere. And yet knowing exactly what an eclipse is doesn't seem to have made it less impressive. If anything, the science may make it more remarkable, because you realize what you are actually watching. You are standing on a planet moving through space at enormous speed. A moon roughly 384,000 kilometers away is passing between you and a star around 150 million kilometers away. Three objects moving through space briefly align. A narrow cone of darkness reaches Earth's surface. And if you happen to be standing inside it, the sun disappears. The shadow then races onward. Minutes later, daylight returns. People cheer. Birds resume their normal behavior. The temperature begins recovering. The corona disappears into the sun's brightness, and the world looks ordinary again. But something has changed, not in the sky, in the people who saw it. Many eclipse watchers describe totality as completely different from seeing photographs or videos. A camera can capture the corona. A television can show the shadow. A photograph can reveal details your eyes may miss. But those images cannot fully reproduce what it feels like when the landscape around you suddenly falls into darkness. That is why people travel repeatedly to eclipses. Once they experience one, some immediately begin planning for the next. But most people on Earth will not stand inside the path of totality on August 12th. Much of Europe will experience a partial eclipse. Parts of Canada and the northern United States will see part of the sun covered. Some areas will see only a small section disappear. And many people around the world will see nothing from their location. NASA plans to stream live coverage beginning at 1:15 p.m. Eastern Daylight Time on August 12th, with views from the eclipse path and experts explaining what is happening. ESA is also preparing live coverage from Spain, so even people thousands of miles away can watch the moon's shadow make its journey. And then it will be over. The eclipse that people planned for years will become history in minutes. The hotels will empty. The telescopes will be packed away. Scientists will begin analyzing their data. Travelers will go home with photographs. Videos will spread across the internet, and the moon will continue along its orbit as though nothing unusual happened. That may be the strangest thing about a total solar eclipse. It feels like the entire universe has changed, but nothing has. The sun is still there. The moon is still there. Earth is still moving. The darkness was only a shadow. But for a brief moment, that shadow reveals things we usually cannot see. The corona, the movement of our solar system, the sensitivity of our atmosphere, and perhaps our own place inside something much larger than ourselves. On August 12, 2026, the moon's shadow will once again race across Earth. It will cross remote Arctic landscapes, pass over Iceland, move across the Atlantic, reach Spain, touch Portugal, and then disappear from Earth's surface. For most observers, totality will last less than 2 minutes. Even at the best locations, it will last only a little longer. Years of anticipation, thousands of miles of travel, millions of people looking upward, all for a few minutes of darkness. But perhaps that is exactly why people remember it. Because some of the most extraordinary moments in nature do not last very long. They appear, they transform everything around us, and then they are gone. So when daylight begins fading on August 12th, when the moon moves across the sun, when the last brilliant point of sunlight disappears and the corona emerges from the darkness, remember what you are actually seeing. Not the sun disappearing, not the end of daylight, but 3 worlds aligning with extraordinary precision: the moon, the earth, and a star. And for one brief moment, from one narrow path across our planet, the universe will turn day into night.